Welcome to another file handling tutorial using the C programming language. In this video, we will talk about how we can use the fwrite function in order to write an array to a file. And then we will see how we can use the fread function in order to read an array from the file. So here, in order to explain this, what I have done is I have created two arrays. I have the array called as data. It contains these values. And then I have this array called as data2, and it has 5 elements, just like the way we have the data array. But in this data2 array, all the elements are containing the value of 0. And then I have a simple for loop here, which is displaying the index and the value of these two arrays at those index. Now, if I save this program and if I run this, we will first take a look at the output. So it kind of looks like this. So it will display the index in first column, and then it will display the data arrays value at the specific indexes, and then data2 arrays value at specific indexes. Right now data array contains these values, and then the data2 array contains all zeros. So here now what we're going to do is we're going to use the fwrite function, and we will write this array data to the file. In the previous tutorial, we have seen how we can write the values of a single variable to the file and how we can read that data from the file. Here we will be writing the contents of this data array to the file using the fwrite in binary form, and then we will read that file and we will store that same data back in this data2 array. So the first thing that we do is we will create a file. So I have opened up this file called as data.bin. I have opened it up for writing as a binary file. And if the file is not opened, then we are returning 1 and terminating the program. If the file is opened, then what we can do is we can use the fwrite function and we can write the data to the file. Now here, this array data has 5 elements. Now when we use this fwrite function in order to write the data to the file, this function doesn't really care what values that we are writing. We just have to specify the memory blocks that we want to write, and it will just write those blocks of memory to the file. It doesn't really care what data that we are writing. It will just write those memory blocks into the file. Now here, when I want to write this data array to the file, I have two options. I can specify each individual element as a memory block, or I can specify this entire array as one single block. Now here, first we will write each single element to the file. So as the first argument, we have to specify where does the data that we want to write is present. So it is present in this data array. So I'm going to specify that here, array name. Now with the variables, we have used the ampersand operator in order to get the memory address. But here, since this data is an array, we don't have to use the ampersand operator. This array name will actually contain the memory address of the first element of this array. So we can write data here. And then we have to specify the size of the single element or single block that we want to write. Since this data array is containing the values of type integer, each element is of type integer. So each memory block here will be the size of this integer type. So what we can do is we can use the size of operator and we can specify size of integer. So for integer, if 4 bytes are used, it will return 4. So for each element, we have the memory of 4 bytes used. So since we are writing each element separately, the memory block that we want to write for one single element is 4, or size of this data type int. And then we have to specify how many elements that we want to write. So in this case, we want to write 1, 2, 3, 4, 5. 5 elements are there. So I'm going to specify 5 here. And then we have to specify the file stream pointed by this fp pointer. Now here, remember, we are specifying each element of this array as a separate block. So each block is of type integer and we want to write 5 elements. Now after that, what we do is we will close this file and then we will open up this file for reading, and we use the fread function. We will read from this file and we will store the elements in this data2 array. I will just copy and paste this code that is already written, read array from the file. And while opening the file, we will open up the file in read mode and as a binary file. If the file is not opened, we will terminate the program. Then we will use the fread function. So it will be fread. Now here, how we want to read the values. We want to read the values just like the way we have stored these values in this file. So we have stored each element as a separate block. So here the first argument is where we want to store the red value. And in this example, we want to store that in this data2 array. So I'm going to specify data2. Again, we are not using the ampersand operator because this data2 is an array. And then we have to specify the size of the single block or size of the single element that we want to read from the file. So again, it will be same as the fwrite. So it will be size of the integer. And then how many elements that we want to read. Again, we want to read 5 elements. And from where we want to read it from this file pointed by this fp file pointer. And then we will close this file. So now if I save this program and if I run this, what will happen is this part of the code will write this data array to the file in binary form. And then this part of the code will read that file and it will store the values in this data2 array. And when this part of the code displays the values of data and data2 array, the both arrays will contain the same values. And now here, before running this program, since this file pointer is already defined, we are just reusing it. So we don't have to declare it. So I can directly say fp equal to fopen, while reading from the file. And after that, I will save the program and I will build and run this. And this time you guys can see the both arrays are containing the same values. So now here, while writing the data to the file, we have written the array elements separately. Now, what if I want to write this entire array as one single element? Now, before continuing, all these things are possible just because for the arrays, data is stored in continuous memory locations. So we are specifying this is the starting memory location. This is the size of one block and you have to write this many blocks to the file. And this fwrite function will write that many blocks of memory to the file. Okay. So now, as I said before, we want to write this data array as a single element. So in order to do that, while specifying the size of one single element, we have to get the size of this data array. So here, what we can do is with this size of, I can use the array name, which is data, and then I can specify I want to write one single element. So now this size of data will actually return the size of this data array in terms of bytes. So this array contains 1, 2, 3, 4, 5 elements. Each element is of integer type, assuming that for integer 4 bytes of memory is used. So this size of data will return 20 bytes. So here for this fwrite function, we are saying I want to write only one element and that one element is of 20 bytes long, and the data that I want to write is starting from the location pointed by this array data. So now if I save this program and if I don't change the way we are reading from the file, again here while writing, we are writing an array as one single element, and while reading, we are trying to read single element of the array. The previous code, I'm not changing it for reading. Will this work? Actually, it will work. So I'm going to save the program, build and run this. We're going to get the same output. Now here, this fwrite or fread function, they don't really care what exactly we are writing. They will write, chunks of memory to the file and they will read chunks of memory from the file. So as long as everything is properly aligned, we don't have any issue here. Now again, while reading from the file, if I want to read an entire array at once, then again here, instead of size of integer data type, I can say size of data array and I can say one element. So if I save the program and if I run this, no issues, the program will run and produce the same output. Now while using this fwrite and fread, we have to be really careful about the size that we are specifying, which is nothing but this number of bytes and the number of elements. We have to be really careful here. The reason why I'm saying is here in this example, I have used this array called as data, which is defined inside this main function, and I'm using that inside this main function. What if I have another function for writing the data to the array? For example, I will create another function. Let me say write array to file, and let's say this function will have the array data, so like this, and then it will have the file pointer, so let us say fp. Now what if I use this particular same code in order to write the array to the file? Will it work? Now what we are trying to do is we are trying to write this array as one element. Now will this work? Actually we have some issue here. When we have this arrays as the parameter of a function, and when we provide this data array as the argument for this write array to file function, this data actually it will behave like a pointer. When we use this size of data, it will actually return the size of the pointer, not the size of the array. Just to show you guys that, what I will do is I will comment out this code, and then I will use the printf function in here, and here I'm gonna say size of the array from function, and then colon %zu, and here I'm gonna use the size of operator on this data array. Okay, now here instead of writing data to the file, I'm gonna do the same thing here. So I'm gonna copy this, I'm gonna paste it in here, and what we do is we will close the program after this particular operation, so it will be return 0. And before closing the program, let us call this function, so write array to file, and we have to provide the parameters. So the first parameter is data array, the second one is file pointer. Actually file pointer is not needed for this example, but since it is already there, let's just use it. And here I'm gonna say from main function, and for this one we have only from function, and then let me insert a new line in both the cases. And now let us save this program and let us run this. And before that, let me just explain what I'm doing here. So what I'm doing is, in this main function we have this array called as data. It contains some values, and here in this main function we are trying to display the size of the array using the size of on this data. And then we have this function called as write array to file, and it takes an array as the parameter. And here inside this function we are displaying the size of that array by using this parameter, by using this argument data. But the thing is, when we have the functions and when they take the arrays like this, the data here inside this write array to file will actually act as a pointer. So this size of data will be different from this size of data which is displayed from the main function. So I'm going to save this program and I'm going to run this. And in fact, here I get the warning because I have set up my editor in such a way that if there is any warning, then they should be displayed. And here it says size of array function parameter data will return the size of the integer pointer. And if I go to the terminal, you can see size of the array from main function is 20, but from the function is 8. The reason for that is when we have the functions like this, and when we have the data as a parameter, they will actually behave like a pointer. So here this one will actually get the size of the pointer of type integer, and that's why we get 8. So about this you have to be careful when writing the data to the file. So all you have to do is you have to make sure that you properly specify number of elements that you want to write and the size of the element properly. Till now what we have seen is about the static arrays. Now what if we have the dynamic arrays in here? For example, instead of this data array, what if I have the data, what if I have a pointer, something like this. Now let us say we get the memory by using the malloc, and before that I'm gonna say int size equal to 5, and here we will assign the memory using the malloc function. So it will be malloc or malloc, and then here we will say size multiplied by the size of integer type. So if the size is 5, then what we are doing is we are assigning the memory for storing 5 integer types of data in this data array. And after that, I will save some values in this data array. I will have a for loop for int I equal to 0, I less than size, I plus plus, and here I will have data and I equal to, let us say, 65 plus I. What I'm doing is I'm using this for loop in order to store the values in this dynamically allocated array data. Now here what happens is if we use size of data, it will not provide the proper size, because since the data right now is a pointer of type integer, it will only return the size of the pointer. So we have to properly set this size here. So what we can do is we can use the size variable which contains the number of elements in this data array. So we can say size multiplied by size of int. Okay, this will properly calculate the size of this dynamically allocated array data. Similarly, while reading the data, we have to do the same thing. So it will be size multiplied by size of integer in this example, because this array is of type integer. So now what we are doing is, since the data array is allocated dynamically using the malloc function, what we are doing is we are properly getting the size of this dynamically allocated array data. So as I said before, the important thing is you have to properly specify the size and the number of elements. And when we use the arrays and pointers, again, beginners can make a lot of mistakes in here. But if you understand arrays and pointers properly, then it will not be difficult. Always remember, you have to properly specify the number of elements and size of each elements properly. So now if I save this program and if I run this, no issues, we're gonna get the proper output here. And for this data2 also, if you want to make it a dynamically allocated array, then you can do that. For example, just like the way we have allocated the data for this data array, we can do the same thing for this data2 array. And then while storing some data, so here I can say data2 array, and the index will be pointed by this I equal to, let's say, the value of 0. And here the data2 will be a pointer now. Okay, so this will also produce the same thing. What we are doing, we are allocating two arrays dynamically, and then we are initializing some values for these dynamically allocated arrays. The first array will contain some values starting from 65. The second array, all the elements will contain a value of 0. Then we are writing the data of this data array, which is dynamically allocated, to this file. And then we are reading that file and we are storing the read data in the data2 array. And then we are displaying that. So I'm going to run this, it will produce the same result. So this is it, guys, for this particular video. Thank you for watching. If you like the video, hit the like button. If you don't like it, hit the dislike button. If you have anything to say, write that in the comment box. For more tutorials, subscribe to the channel.